This review lesson is about getting you up to speed on rationalizing denominators. If a fraction contains a radical, which is basically a square root in our case, in its denominator, then the fraction is considered to be not fully simplified. To simplify it, we multiply the fraction by a constant equal to 1 that removes the radical from the denominator. So for example, let's rationalize the denominator of the following fractions. Now luckily, in trigonometry, we don't need to do very difficult examples, but we actually end up doing quite a few examples. So you need to be very good at this process. So 1 divided by the square root of 3, for instance. It has a radical in the denominator of the fraction, and therefore it's not fully simplified. To simplify it, we multiply by a fraction that equals 1. So I'm multiplying by the square root of 3 divided by the square root of 3, and the value of that fraction is 1, because any number divided by itself is just 1. But when I multiply this through, 1 times the square root of 3 is the square root of 3. The square root of 3 times the square root of 3 is the square root of 9, and the square root of 9 is 3. So now there is a radical that exists in the equation, or in the fraction, but it's in the numerator and not in the denominator. So this is considered to be fully simplified. So as long as your radicals exist only in the numerator, it is fully simplified. So let's try another example. Five divided by the square root of 12. Now, the obvious thing to do here is to multiply top and bottom by the square root of 12 over itself. So let's start there. So 5 square root of 12 divided by square root of 12 times the square root of 12 would be the square root of 144, which is just 12. This is how this is always going to end up working. This isn't fully simplified though. The other caveat is that you have to reduce your radicals as much as possible as well. So for instance, in this situation, 12 could be written as 4 times 3. And since 4 is a perfect square, you can actually take the square root of that, because you can split a radical up by multiplication. So that the square root of 4 is 2, and I'm doing this in a lot of steps. Most of these you'll get to the point where you'll just do it in your head. That 2 now shares a factor with the 12. So let's cancel that out. So we have 5 square root of 3 divided by 6. That's the fully simplified answer here. And that's what the answer in the homework is going to be looking for. A few more examples here. Square root of 25 over 7. So when you're taking the square root of a fraction, you can split that square root up about the numerator and the denominator as well. So you can split a radical about multiplication or division. That's fine. So this ends up being, because 25 is a perfect square, 5 over the square root of 7. But we haven't gotten rid of the square root in the denominator, so we still need to multiply top and bottom by square root of 7. So we're going to end up with 5 square root of 7 over 7. Here's another example. So we'll start with just splitting this up as such. So square root of 5 divided by square root of 12. Now, I think what I'm going to do before I multiply top and bottom by the square root of 12, knowing that I need to simplify that thing anyway, I'm going to go ahead and do that first. There's really no right or wrong way in that. You can choose to start wherever you want. I'm just choosing this. So 12 can be written as 4 times 3. 4 is a perfect square, which can come out of the root. So that'll change into 2 square root of 3. Now I need to get the square root of 3 out of the denominator, so I'm going to multiply top and bottom by that value. So square root of 5 times square root of 3 is going to be the square root of 15. Square root of 3 times square root of 3 is just 3. 2 times 3 is 6. There's the most simple form of that answer. Lastly, 3 divided by the square root of 5x. I'm not sure that you'll run into anything even as complex as this in trigonometry, but I thought I'd throw this example out just in case. So we multiply by the square root in the denominator over itself, so exactly as we see it. So this becomes 3 square root of 5x. And even though there's an x involved here, it's no more complex than the previous examples. The square root of 5x times the square root of 5x. It's the same thing as squaring a square root, which cancels itself out, so you end up with just 5x. There's nothing left to reduce here. 3 doesn't go into 5. This is as far as we can take it. So this is the final answer.